Welcome to EDU World Space.
So it is estimated that 10% of the population has a disease. So if you were to pick somebody at random, the probability they have the disease is 10%, 0.1. There's a test available, but it's not perfect. Now, we're going to write this as conditional probability. So the probability that somebody is misdiagnosed as healthy, despite the probability they have the disease, despite them having the disease, is 2%. So we'll put this as A prime, so that is not diagnosed as having the disease. So they've said A is having it, or rather being diagnosed to have it. So being told you don't have it, given you have the disease, is 2%. So given someone has the disease, so given they have a disease, probability of being diagnosed as healthy, 2%. Probability of being diagnosed as having the disease, given they don't have it, so D prime, is 3%. And of course, the probability of not having the disease is 90% of the time. So we've extracted the information from the question and put it in probability notation. Probability of disease, 10%. Probability of not being diagnosed, given disease, 2%. Probability of no disease, 90%. Probability of diagnosed, given no disease, 3%. Now, we want the probability somebody is actually sick given they were diagnosed as having the condition. So D given A. And we are going to be using Bayes' formula here. We write it down. The probability of Y given X, this is Bayes, probability of Y given X is equal to X given Y multiplied by Y divided by X. So let's apply that here. So we need A given D. Well, I know not A given D. A would be the rest of the time. Either you're diagnosed with a condition or you're not. Probability of not being diagnosed is 2%, so A given D is 98%. Notice I'm using decimal form here because percentages don't play very well with calculations. And they actually tell you this as well, that P of A given D is 0.98. And we multiply that by probability of disease. So we've got A given D multiplied by D, and we divide that by probability of A, which I don't have, but I can find. There are two ways somebody might be diagnosed as having this condition. They are diagnosed and they have it, or they are diagnosed and they don't have it. Everyone either has the disease or they don't, so that covers both ways this could happen. To get the intersection, you just use the numerator here, X given Y times Y. So A and D is A given D multiplied by D. A and not D is A given not D, 0.03, times no disease. It's a kind of weighted average. So let me find this. 0.98 times 0.1 plus 0.03 times 0.9 is 0.125. I'm just dividing this now. We get 0.784. Probability of having the disease given they were diagnosed as having it.